For the last few days, space enthusiasts across the planet have been watching as Crew Dragon resilience has been changing the world of low Earth orbit forever. The success of this new reusable ship means that the ISS will now have a crew of 7 again, and will be able to focus more on scientific tasks instead of the maintenance of the station, strengthening the argument that the station should stay in operation rather than being shut down as planned. But in addition, we can watch images like this with a sense of excitement, knowing that not too far from now, and as a matter of fact, starting next year, SpaceX is going to start taking tourists into low Earth orbit. Anybody will be able to see sites like this, well, provided that they have quite a lot of money. And yet, as exciting as this ship is and what it means for the future of manned exploration, we must remember that we're still stuck in low Earth orbit, where man has been for 50 years, and we haven't seen a site like this once again in nearly half a century. And as a matter of fact, this particular site was not actually beheld by human eyes. It was an unmanned satellite called the Kaguya, which slammed into the moon about 10 years ago, after providing us with a huge amount of valuable information, of course, and views like this, which brings back a sense of nostalgia and, to me, a little bit of sadness. Actually, make that a little bit of sadness and a hell of a lot of anger, because as all of us know, it is long past time for us to go back to our satellite, or someplace else besides low Earth orbit, which is why the International Space Exploration Coordination Group came up with a roadmap for exploring the moon and then Mars beyond that. And I covered part of this plan in a previous episode, and now it's time to cover the rest, or at least as much as I'm able to. How are we going to be able to carry all of this out? Well, like Mars, the plan for the moon starts off small, with a bunch of orbiters and also robots like the Canadian Space Agency Juno that you see here, but it eventually graduates to biodomes on Mars. That's a pretty big leap, and the title of this video, and I'm going to explain exactly how that's supposed to be accomplished, and also a little bit of annoyance, because the first country to actually do anything about this has been the People's Republic of China. Since this is part 2 of a 2-part series, I'm foregoing my usual introduction, so if you haven't seen part 1 of this series, I have it linked in the description, and please watch it before you watch this one. That having been said, the plan put forward by the ISECG, as they are called, is a plan to establish a permanent human presence on the moon and use the technologies and what we learned there to establish a permanent human presence on Mars. And the logic behind this is pretty obvious. Both of them have extremely hostile environments. Both of them have high radiation levels, although the moon is substantially higher. Both of them have incredibly cold nights. Both of them have extreme life support problems, for humans anyway. So both of them are challenging places, except the moon is a lot closer and therefore much easier to conduct our experiments on before we embark on a 6-month journey to the Red Planet. Now, the first step of the plan involves doing something that Apollo did not, and that is sending a series of robotic rovers and orbiters to determine the best locations for humans to land and also to determine the locations of the best types of resources for long-term habitation. As you can see from this chart, the Chinese, through the Chang'e 5, are putting the first of these rovers on the moon, but what it doesn't show is that the Chinese already have a rover on the moon, the Chang'e 4, which most of you have heard about, that currently is exploring the far side of the moon, close to the South Pole, where we are likely to establish a base. The Chang'e 5 mission, however, is entirely different, bound for the Mons Rumker volcanic complex, where it's going to acquire at least 2 kilograms of lunar material and bring it back to Earth in the space of only 3 weeks. Now, Mons Rumker is a fairly recent volcanic complex and should have some pretty unique geological samples. In addition to that, it's high in ferric oxide, which can be used in solid rocket fuel. So by the end of this year, the Communist Chinese will have deployed 2 of the robotic probes necessary to this overall plan, and the rest of the world will have deployed 0. However, in 2021, NASA will respond in kind, using a Vulcan rocket to deploy the first of the Commercial Lunar Payload Services, or CLPS. The Astrobiotic Peregrine lander, which was originally supposed to be deployed by an Atlas rocket, has a whole host of scientific packages on board, including LiDAR for precise landing, photovoltaic lunar surface systems for high-efficiency solar panels for longer duration missions, and also instruments designed to detect the exact radiation levels at the lunar surface. It's also equipped with a variety of mass spectrometers to determine the exact composition of its landing site, and NASA is hoping to find not only water, not only CO2 to be made into liquid oxygen, but also methane. Yes, methane. It seems highly unlikely, but if they do find it, that means methalox fuel can be manufactured on the moon. Now, in general, methane only appears in any kind of quantity when you have large amounts of life or active volcanism, neither of which seem to be the case on the moon. But if the moon throws us a surprise, the Peregrine lander could change everything for the Lunar Starship and SpaceX's activities on the moon. In 2022, the Maston Corporation will put its lander on the moon as part of the same program, again looking for things in the moon's composition that could be useful to habitation, including methane. Do they know something that we don't? And on top of that, to determine the nature of the lunar regolith and its damaging qualities. The lunar regolith proved to be a big problem to the Apollo missions, and we want to determine the best ways of controlling it for future missions, not only for the moon, but also for Mars, where the regolith is not only damaging, but also poisonous if humans happen to be unfortunate enough to inhale it. And by the way, if this company sounds familiar, it's because they intend to upsize the scale of their lander until eventually they have something that can take off as well with cargo, and that's the Maston Zeus, which integrates the upper stage of the Vulcan Centaur's rocket, and this will be able to carry ultimately 25 tons up into lunar orbit, either to a waiting Lunar Starship or to another second stage Vulcan Centaur used as a tug to bring these materials to low Earth orbit once the lunar economy is established. Now, all of these robotic missions are just precursors to this mission, the Viper, which is designed to find water on the moon, and that's just about it. It's a very large rover, over 400 kilograms and the size of a golf cart. And since we don't know a lot about the lunar regolith at the South Pole, the earlier missions that have studied the lunar regolith will help this very large rover from getting stuck as it proceeds on its 100-day mission. Unlike the earlier missions, the Viper will also have a 1-meter drill designed to pierce the lunar regolith, which may be quite hard at the South Pole, although earlier missions will determine that fact, and this will give us the clearest picture of exactly where water ice is at the lunar South Pole and the most appropriate places for the first lunar landers to start setting down. The Viper is going to be the preeminent scout for our future missions to the moon. Oh yes, and by the way, since the Viper will be operating in shadowed areas of many craters which have never seen sunlight, it will be the first with headlights, but it will also give us, as I said before, a complete picture of the moon, its valuable resources, and the best place for astronauts to set down and start establishing bases using the Lunar Gateway as a base camp. It's a very comprehensive plan. But other nations are not going to remain idle during this time. The Luna 25, which is designed to gather much of the same information, is going to be landing at the lunar South Pole next year if things hold up, and it's not the only one. There's also going to be the Japanese SLIM probe, which I described in the last episode, and also the Chang'e 6, which is yet another sample return mission, along with a French experiment to determine the nature of the lunar regolith. A lot of the same experiments being repeated with the same goal in mind, to establish a base at the lunar South Pole. Do we have a new space race going on? Damn straight we do. Once human activities begin on the moon, extensive EVA operations are going to be essential, not only in terms of doing useful work on the moon, but also in determining how well humans perform for long periods of time in EVA suits, because when they're on Mars for hundreds of days, they're going to be in these suits on a pretty regular basis. Also, developing new ways of mitigating lunar regolith and dust is going to be extremely important as well. Whereas lunar regolith may be just inconvenient on the moon, the regolith on Mars, because of the perchlorates, is downright deadly. Although the perchlorates can also be used as an emergency oxygen supply and for solid rocket fuels, and I have a video about that linked in the description. And of course, after the first couple of missions, we're going to have to be dealing with the moon base. And as you can see, the Earth has every advantage and the moon has virtually none. Balanced temperatures, protection from radiation, an atmosphere that we can breathe, pretty much everything that we've evolved to deal with, whereas the moon has virtually none of that. And this is the kind of environment that we're going to have to learn to survive in if we're going to prove that long-term survival on Mars is possible. Obviously, the moon has no atmosphere, no protection from radiation or meteoroids, an extreme difference in temperature. The nights get ridiculously cold there. As a matter of fact, it's a far more harsh environment than Mars in most respects, although not all. Now, this ESA video gives only one concept for constructing habitation domes on the moon, and in this case using 3D printing and the moon's regolith to provide protection from radiation and the other hostile environments of the lunar surface. Now, since NASA, through a variety of contests, has come up with a huge number of different ways to do 3D printed habitats on Mars, the moon would be an excellent place to experiment with them. They start out small, for 4 crew members or so, for a 30-day time period. Now, although some advocate living completely underground, the ESA and NASA believe that psychologically, especially if we're talking stays of hundreds of days, it will be better to have habitation domes on the surface and to simply cover them with regolith to protect them from radiation and other hostile conditions. Now, if the initial rovers and landers have done their job, then they've identified the best locations that have the most water ice and the most usable materials in order to build the largest structures. And so, bit by bit, these habitats start getting larger. Now, as you can see, this one is not particularly huge, again for a few astronauts for a 30 to 45 day time frame. However, it does come with a 3D printed protective outer membrane, solar radiation protection as you can see, and also protection from meteoroids, quite a lot here, an airlock where you can hopefully get rid of the regolith, and also natural daylight, a big positive as far as NASA is concerned and as far as I'm concerned. And as these habitats grow, their power supplies grow as well until they have 300 kilowatts worth of power being generated locally, and habitats start becoming cities, growing their own food, generating their own in situ fuel and power until you have a biodome. And this may be a pretty grandiose example of the end result on Mars, but nevertheless, the plan calls for the colony to be able to sustain itself for 500 days. You can't do that unless you're growing a lot of your own food, making your own oxygen, making a lot of your own in situ fuel to go back, because that is the assumption of the plan. After 500 days, you do go back, so you're going to require something like this. Now, of course, this could be accomplished with hydroponics and smaller structures, but the principle is the same. You start off with robots which identify where the resources are, and then slowly but surely you build up your capacity until eventually you prove that you can sustain yourself in a hostile environment for a long period of time. And then, and only then, do we attempt a 3-year adventure, essentially is what it comes out to, in going to Mars. And this is what this plan's endgame is. And I have to admit, although it does have its flaws, it is very compelling. And only if we could get all of the space agencies and all the nations of the world to buy into it. Do you know what bothers me the most about this plan? Well, it's a really good plan, don't get me wrong. But it isn't the fact that these guys are, well, so important in it as far as the SLS is concerned. There are other replacements that theoretically we could use if the SLS never pans out. And it isn't the fact that the Chinese seem to have taken a lead and seem to be completely determined to complete their task, whereas the United States and its allies, especially the US, seems very fickle about the whole thing, very unenthusiastic compared to the Apollo program. And I'm not mad about that because it's the Chinese. I want to make one thing perfectly clear. If the People's Republic of China establish a moon base before the Western powers do, more power to them for having the foresight to do it, even if they use it for military purposes. Because frankly, we had it coming to us if that is indeed the case. And it wouldn't be the first time. The Western powers underestimated the Japanese, for example, during the Russo-Japanese War. The United States underestimated the Japanese before Pearl Harbor. As a matter of fact, it was a commonly held belief that because Japanese boys were carried on their mothers' backs when they were babies, they didn't have the proper balance to be fighter pilots. Can you believe that? And we found that very much not to be the case in the next 6 months of the war, at least. And then, of course, there was the infamous crossing of the Yalu River when MacArthur chased the North Korean troops into China, thinking that they wouldn't have the guts to counterattack, and they did, by the hundreds of thousands, nearly driving the Allies off of the Korean Peninsula and creating one of the bloodiest stalemates in military history. All of these things from underestimating Asian powers. So I say if we underestimate China, it's our own fault, and more power to them for expanding into space and having the guts to stay committed to it if they're the ones to do it. But all of that having been said, that isn't actually what I'm the angriest about. It's the concept of 500 days worth of habitation. The notion that we have to be established on the red planet or on the moon for 500 days and prove that that's doable before we actually embark on a journey to the red planet, because that's expecting a lot from astronauts, a hell of a lot. 6 months on the way there, 500 days in 1/3 gravity, and 6 months on the way back. We have yet to even simulate what that's going to be like. And if we do it on the moon, it's still not going to be the same because the gravity is only 1/6 of the normal gravity. And that's a common response I got to my last video on the Mars Direct 3.0. The objective should be to go to Mars to stay, to colonize, not to come back. And I do tend to agree with that. I think that the astronauts who do go on the first mission to Mars should go with the expectation of not coming back, of Mars being the most important thing in their lives. It may be difficult to find trained astronauts who are that determined to colonize the solar system, but I tend to think that they are indeed out there. And the idea of coming back should be a fallback, a fail-safe, rather than an assumption. Our first expedition there should be the one to stay, because coming back after all those years in gravity significantly lower than that of Earth is going to have a terrible, terrible impact on the bodies of these astronauts who had the guts to go in the first place. And so if they're the types of people who want to go to the red planet to stay, they should have that opportunity. But that's my belief, and I'm sure there are many others, and I'd be interested to see your views in the comments. Well, the cup is still here. We're past 31,000 subscribers at a record pace. We could get to 40,000 by the end of the year. I'm very excited to see if that happens. In the meantime, if you want to see more plans for the exploration of the solar system, more things that NASA is doing and other space agencies are doing that doesn't get reported on a great deal, then please support this channel. You know how. It's all in the description. There are many ways to do it, and I'd be deeply appreciative even if you just subscribe. So, until we are ready to commit to explore this solar system with as many nations that are willing to come along for the ride, for real, as cooperative partners and not as adversaries, I urge all of you to stay angry about space.